In this video, we will cover question 3 of exercise 5.2. We are told to draw these two graphs at the same time on a given axis, over here, the x and the y axis, and state whether these two equations have no solutions or infinite number of solutions. Right, so before question 3, we found out that in question 2, as well as in question 1, when we are drawing two graphs, two straight lines on the same axis, where the 2 points intersect, that will be our solution. So the solution for these two equations is x equals to 1 and y also equals to 1. For these two equations, where the two graphs intersect, the x solution is 0 and the solution for y is 1. For part C, the two graphs intersect over here, therefore the solution, the answer for x is 0.5, the answer for y is 1. For part D, the two graphs intersect at this point, so the answer for x is 0, the answer for y is 7. So we see this pattern over here. Then in question 2, we are told to plot the graphs ourselves. So the two graphs that intersect here, which means that x has a value of 0.8, the answer for y is 1.4. We continue, two graphs intersect here. The answer for x is negative 0.6, the answer for y is negative 3.4. We are just reading off the coordinates, in other words the block and the level, for the point where the two graphs meet. So same for part C, they intersect at this point. Then the answer for x and the answer for y are just read off from the graph. Part D, they intersect here, solution for x and solution for y. Now, let's begin with question 3. We always like to make y the subject from the given equation, because from there we can tell what the y-intercept will be, we can tell what the gradient will be really quickly. Also, we will be able to find the values of y much faster. So from here, let us make y the subject. We subtract x on both sides. So we have 2y equals to 5 minus x. Next, we divide by 2 on both sides. So y equals to 5 over 2 minus half of x. Oh, we would rather write it this way. Y equals to negative half x plus 5 over 2. Because from here, we can tell that negative half is the gradient and 5 over 2 is the y-intercept. So here we have a table. We get to substitute in values of x that we want. Now I like to select x, one of the x values as 0, because when x is equal to 0, we have this block, okay, block 0. That is our y-axis. Once we find out the corresponding value of y, then we will already have the y-intercept. So let us substitute x equals to 0 into the equation that we just did. So y equals to negative half times of 0 plus 5 over 2. And we have a y coordinate of 5 over 2, which doesn't surprise us because we already mentioned that the y-intercept is 5 over 2, which is 2.5. So let us count. This is level 2, this is level 3, so level 2.5, which is 5 over 2, must be in the middle. Let's continue. By choosing other values of x, you are free to choose any value you want, but there are some values that will be more suitable. For example, let's choose x as negative 3. So y equals to negative half times negative 3 plus 5 over 2. So calculate this out with your calculator. We will see that we get a value of 4. So we are looking for block negative 3, level 4. This is block negative 3. I'm using a dotted line, and here we have level 4. This is the point that we are interested in. Next, suppose I choose 2 as my x coordinate for the last set. Let's change this to 2 plus. So when x is equal to 2, when I am at block 2, my y value is 5 over 2 minus 1. That is 3 over 2. That's 1.5. So block 2, level 1.5. This is the point that we need. So take our ruler. Join up the points. Label your graph. Okay. Label your graph according to the equation given, x plus 2y equals to 5. Now let us move on to the next equation. Again, we want to make y the subject. So we have 4y equals to 6 minus 2x. We divide by 4 throughout. We arrive at y equals to 6 over 4 minus 2 over 4 times of x. Do some simplification and rearranging. We arrive at negative half x plus 3 over 2. So before we plot the graph, I want you to look at the gradients of these two equations. We've got negative half, we've got negative half here. They have the same gradient, which means that we expect these two lines to be parallel to each other. Okay, so now we get to choose our x values and we calculate the corresponding y values. So as mentioned, I like to have 0 as one of my x values. When x is equal to 0, this is going to be my value for y, 3 over 2. Next, when x is equal to, you get to choose. So for example, let's choose negative 4. Y will be equals to negative half multiplied by negative 4 plus 3 over 2. So negative 4 divided by negative 2 is simply 2. So 2 plus 1.5, we get 3.5. So when x is equals to negative 4, we have 3.5. That's our y value. Right? So 3.5 is equivalent to 7 over 2. Now we need to find another value for x. Again, you get to choose anything you want. For example, let's choose a value of 3. When x is equal to 3, we have a y equals to negative 3 over 2 plus 3 over 2. So this will be 0. Now we have 3 points. As expected, these two lines are parallel. So write down the equation of this graph, 2x plus 4y equals to 6. Now we are ready to answer the question. State whether the pairs of simultaneous equations have no solutions or infinite number of solutions. So earlier in question 1 and 2, we found that when there is one point of intersection, that particular x and y coordinates will be the solutions. But in this case, do these two lines ever intersect? No, they don't. They are parallel lines. Since the two graphs are parallel, they do not y-intercept. Therefore, there is no solution. They do not cut each other, so I cannot have a common x and y coordinate at the same time. So please write this down. Next, part B, same type of question again. Again, we make y the subject. So 3y equals to 4 minus x. Y will be, we divide by 3 throughout, 4 over 3 minus 1/3 x. So I prefer to write it this way. Y equals to negative 1/3 x plus 4 over 3. Now we have to choose our x values. Let's put in some values, say negative 4. Let's put it in 0. And let us put in 5. Okay, let's switch that. Okay, we see what happens over here. Okay, so let us substitute. So y equals to negative 1/3 times negative 4 plus 4 over 3. So you can use your calculator for this. So negative 4 times negative 1/3, we get 4 over 3. So 4 over 3 plus 4 over 3 is 8 over 3, which is actually 2 and 2/3. Now what this means is that at block negative 4, our level is 2 and 2/3. Now we know that 2 is over here, 3 is over here. Are we able to really exactly find out where 2 and 2/3 is? Or are we only doing an estimation? So if we are doing an estimation, is that good enough? Okay, so an estimation over here is not good enough. So our conclusion is that choosing x equals to negative 4 may not be such a good idea after all, because I will end up having to estimate where this 2/3 is. How about if I change this to negative 5? Let me choose an x value as negative 5. So I have 5 over 3 plus 4 over 3, which is 9 over 3, which is 3. Now I know that at block negative 5, my level is 3. This is the required coordinate. Okay, so we can remove all these dotted lines to make things neater. Now when x is equal to 0, we have 4 over 3. Okay, so that is our y-intercept. But again, 1 and 1/3, it's not that easy for us to identify exactly. So perhaps we should switch it. Instead of choosing 0, let us choose, for example, 1. When x is equal to 1, y will be equal to negative 1/3 plus 4 over 3, which is 3 over 3, which gives us 1. So when x is equal to 1, block 1, our level is also 1. Now next, let us choose a value for x. Another point, we need 3 points. So is x equals to 5 a good choice? So we can calculate this really quickly. 4 over 3 minus 5 over 3, no, I will still need to do some estimation. So that is not a good choice. How about if I choose x value of 4? Now we have negative 4 over 3 plus 4 over 3, which is 0. Okay, that is convenient. So when x is equal to 4, y is equal to 0. So here are my 3 points. Join them up. Label x plus 3y equals to 4. Now here we have the other equation. Again, we make y the subject. Dividing by 9 throughout, we have y equals to 12 over 9 minus 3 over 9x. Do some simplification. 4 over 3 minus 1/3 x. Rearrange them. Y equals to negative 1/3 x plus 4 over 3. Does this look familiar? They have the same equation. So if they have the same equation, what do you think will happen if I substitute in the same values of x, negative 5, 1 and 4? Do the same calculation. Of course we will get the same y values. If we have the same y values, then our points have the same coordinates, which means that it is a repeat of the same points. Joining them up again, so we just draw over the same points, over the same line one more time, and I label it 9y equals to 12 minus 3x. Then think about it. Do these two graphs actually intersect each other? Do they cut each other? Because right now we are trying to find out the number of solutions. And turns out they do. They intersect at every single point because these two graphs are the same graph. So since the two graphs are the same, they intersect at infinite points. Therefore, they have infinite solutions. Alright, so in summary, if intersect 0 times, there's no solution. If intersect 1 time, it means one solution. If intersect 2 times, it means 2 solutions. And we can keep going. If intersect infinite times, it means infinite solutions. So here, when they intersect 0 times, it means parallel lines. Intersect infinite times means they are the same line.